Thank you, everyone. So, good afternoon, everyone, and welcome. My name is Francisco Riveros, and today we are going to explore how the cloud-native ecosystems can contribute to a more sustainable future. Well, you will be asking, what is sustainablecloud.com, which I put here. Well, as I am a cloud and solution architect since a long time, I always I'm interested about performance and FinOps. But I started to realize when I talk to customers that they are always present, which is sustainability. So all you know that we have a climate change issue. We have to fight to the climate change, and we are seeing more and more news stories about extreme climate events and such as heat waves, droughts, melting ice caps, and so on. So that's why I decided to create this website where we can share information and about what we can do as IT people. No, but what really is sustainability? Sustainability in 1987, United Nations defined sustainability as the ability to meet the needs of the present without compromising the ability of the future generation to meet their own needs. Today, there are almost 140 developing countries the world seeking ways of meeting their development needs, but having in mind climate change and others. I know this is a complex issue, but is one that's becoming increasingly important for businesses as well. You can see here clearly 31 of the German CEOs want to invest more than 10% of their revenue into making their organization sustainable. Or sustainability has grown 303% in CEO importance in 2021, and the majority agree that climate change needs to be addressed urgently. So you can see here is that businesses are trying to move to a more sustainable way. But why? Sustainability is a trend because customers, you, us, are looking for more sustainable products and services, and businesses are being seen as a sustainable company could attract investors and could attract more customers. Also, there are more and more organizations that have signed up the climate pledge, which promise to achieve net zero carbon by 2040, meaning that governments are increasingly regulating business to reduce their environmental impact. Another point is that the employees are asking internally about what they can do for sustainability inside of the organizations, and also is seeing that employees are seeing better or having employee satisfaction and retention if the company take a look of sustainability in their goals. Also, investors are being attracted to put money, or to put more money, or put only money in organizations that are being sustainable or like are with goals with sustainability. Let's say like BlackRock, as for instance. And sustainability can really drive growth. What means that? As a study in Accenture, one study from Accenture shows that businesses grow 2.5x growth or 2.5x outperform as their competition, just to be as being a company as sustainable. But you will say, okay, but now how we can start? Well, sustainability is a journey. First is to start with measuring your carbon footprint, right? Because without these metrics, we cannot do really nothing. Observability is really important. So it really doesn't make any sense if we don't have this information. Then we talk about how to architect for sustainability, which is what we are going to talk, or what I'm going to talk today. And lastly, we have the touch upon sustainability transformation, how you are going to transform your organization processes to achieve these goals. But then we need to have some common understanding. How many of you knows what sustainability in the cloud means? May you raise your hands? Nobody? Great. Well, I can show you some definition here that I have from a cloud provider is from AWS. Sustainability in the cloud is a continuous focused effort on energy reduction and efficiency across all components of a workload. I have highlighted the words of continuous energy reduction and efficiency because they are kind of keys in this topic on what we are trying to accomplish in the cloud. So let's have a deeper look what the main clouds are doing. AWS is a positive player according to Gartner, and they aim to power its operations with 100% of renewable energy by 2025 and net zero carbon by 2040. Azure Cloud is also classified as a positive player by Gartner, and with the same commitments in timelines from like AWS, sorry. And lastly, Google Cloud, and as a strong player with dedicated responsibility to run all their data centers in carbon-free energy by 2030. This is really a huge commitment and a huge challenge that makes this these main cloud providers are making. Since to be in the cloud can help organizations to reduce the carbon emissions and facilitate sustainability, innovation, and research. The cloud plays an essential role in this, helping the organizations to become more sustainable. But let's see, how green are their data centers? So in order to compare an equal methodology of data centers, I have chosen a company called climatic.io to show how they calculate the carbon footprint on each data center and ascertain methodology, which I showed there. And according to them, we could see that the greener data centers in AWS are located in Sweden, France, Brazil, and the not so green in areas like Africa, Hong Kong, and Australia, which we can see kind of a pattern, no? Where we can put the data center in a desert or in a location where the energy or cooling is hard, is also bringing some consequences. Here we have Azure. We can see here the greener are in UK Cardiff and UK London area and Ireland, and the not so green for the same pattern Hong Kong and India. And here we have Google Cloud with the greener data center in Switzerland, Brazil, US Oregon, and then also green Indonesia, Australia, and India. So now that you are aware of data centers and how they operate in this field, we could move into what see in the cloud. How many of you are familiar of the cloud responsibility model? Yeah, 1, 2, 3. Well, good. Perfect. Thank you very much. Well, this, when it comes to sustainability, is also the same concept. Sustainability in the cloud is a shared responsibility. The cloud providers must ensure that their data centers are an underlying global infrastructure run efficiently as possible. And it's up to us, builders, to ensure that we are architecting, designing, and building sustainable ecosystems. But then, how we can architect for sustainability in the cloud? That's a great question. But there are a number of best practices that we can follow to make our cloud architectures more sustainable. In the next slide is when I'm going to show you some best practices, some of these best practices. So yeah, let's have a look. First, if you are already in the cloud, congratulations. You are in the green path already. You are being greener. As you saw, there are different types of clouds, different types of regions, and different strategies. Some studies indicate that if you move from a typical enterprise data center to the cloud, you could save more than 80% reduction in energy moving your workloads to the cloud. So we are being already more sustainable than a traditional enterprise data center. I hope you all know what National Geographic is, what it's doing. They try to raise the awareness of the environmental issue to people through pictures and some other activities. In this way, they have their own photo library in the data center, their own data center. And when they move to Google Cloud, they reduce the emissions by 16,000 kilos CO2 per year, which is huge. In comparison, you can compare that it's burning 9.2 tons of coal, which could take more than 15 football fields of forest to capture. The reduction of the emissions was achieved in a number of factors, including using more efficient data centers technologies, locating their data centers in areas to access to renewable energy, and using demand scaling to only use resources when they need. But then you are in the cloud, okay, but now how you are aware of what your workloads are doing or what are affecting to our environment, how we can do that. For that, we should enable observability. So here we are some observability tools for each cloud. AWS, I have customer carbon footprint tool, it released in 2021. Azure has introduced sustainability calculator in 2020, and GCP, Google Cloud Platform, released carbon footprint tool in October 2021. In October 2021, exactly. So these tools help customers to understand the carbon footprint of their cloud usage. This information can be used to make more sustainable choices when we use cloud services. So this is an example. Wait, sorry. So this is an example of a carbon footprint tool of Google Cloud that it provides gross emission by project, by product, or by region of your workloads, recommendations, and many other metrics. Take a look in your own cloud what they provide to start available to check these metrics, because they are really important. So the third one in the best practice is to choose the right region. So when we decide to in a region, we often take into consideration, the cost and latency, no? But we also should consider what regions are running in the most sustainable way. Let's see that in a concrete example. Let's imagine that we have an N1 standard 4, which is a Google Cloud virtual machine, which is a 4 vCPU, 15 giga RAMs. And we want to move to another greener region. So the only possibility that we have, according to the requirements, we have Frankfurt and Netherlands. But before that, let me explain what you can see in there. What is really CFE? CFE means that what is the percentage of energy we consume in our application is running on a carbon-free energy. And GCI is the grid carbon intensity, which indicates the average operational gross emission per unit of energy from the grid. Yeah, there's a little bit kind of complicated to understand, but please follow me with the numbers. So then here we have Frankfurt with 60 CFE, which means that it's quite good, but we can do better. No? And we have Netherlands with 53, which is less, but the price is cheaper than Frankfurt. But we can do even better. So we know that we have Finland, no? Which is CFE is 91%, and is greener and is also cheaper. So if we moved from Frankfurt or from Netherlands to the same workload, the same machine, which is running in these locations. We are not moving to a more greener region to move to Finland. But in this case, we are moving and saving cost because it's cheaper. The fourth one to say is please align to demand. Because the workload running, but we need to align with the demand. But for example, serverless architectures, allow you to use only the resources you need and when you need them. So this comes with many benefits: cost reduction, scalability, reduction in security overhead, but it's also help us to improve sustainability. This is simply because we don't use as much electricity as we do for traditional server-based architectures. And we can take a look in your own cloud what possibilities we have. In AWS, we have Lambda, Fargate, and Azure functions and container instances. And GCP, we have Cloud Functions and Cloud Run. So if we see this in a concrete example, let's imagine that we have a batch process where we're first running in a typical compute engine machine. We call the APIs, and we run this. We complete batch process took 24 hours. But if we took the same process, the same batch process to a serverless flavor, we saw that the same batch process would take that in 2 hours of reduction and reduction of CO2. How we efficiently share the infrastructure resources by executing only the functions only on demand, and for that we are saving time and saving CO2 emissions. Let's see that more in detail. So here we have service, our infrastructure as a service, and from one side, and serverless from the other side. Here we have our virtual machine, which is always running. As you can see, this is a traffic of the workload and has some peaks, and sometimes nothing. But in terms of resources, we are always reserving 100% of CPU and 100% of memory. So, on the other hand, we have the serverless workload, which has the same pattern, the same workload pattern, but with the difference that we are not running all the time, just when they need to run. And in the same case, we use resources just when we need it, while it's helping to reduce our energy usage and CO2 emissions. Next, other important best practice is to review our service level agreements and disaster recovery plans. When we architect for resiliency, we should consider the environmental impact in our requirements so we can reduce the environmental impact by using non-instance failover instead of instance failover, optimizing the placement of our workloads and the number of instances. So let's see this in an example. We have an application which requires a maximum of 4 vCPUs, 16 GB, and we need to have an instance failover in an availability zone when it goes offline. So in this case, in the second availability zone, it's always running my application. So in the case of failure. But what if we consider to run this app in 3 availability zones, if the business case on our software, if the application support that, to run to 2 vCPUs and 8 GB. So only we have an excess of capacity of 2 vCPUs and 8 GB. In this case, we are saving cost, in the sense of resources, and we have still, in the case of failure, we have 2 instances running in other availability zones. 6 is reduce your data usage. So you really know that every day we are collecting and gathering more and more data for the world. Well, for that reason, help is to reduce your data usage. The more data you store and process, the more energy your application will use. Try to reduce your data usage by compressing data, deduplicating data, or deleting unused data. Also, try to adopt a mature deployment approach and ask yourself, do we really need to deploy multiple environments? Or do we really need to have running the test environment over the weekend? So try to automate these kind of things. And with that, in this point of automation, we could help to automate data retention policies to help the storage lifecycle management. So we have here some policies that solutions that help us to retain data as a required amount of time, and while also we are reducing our environmental impact. So in S3, we have lifecycle for lifecycle policies in AWS. Google Cloud, we have object lifecycle management. And in Azure Blob or storage, we have lifecycle management policies. And lastly, please educate your team. Make sure that your team is aware of the environmental impact of the cloud computing and how they can help to reduce these emissions, giving information, giving tools to do it. For that, I wanted to present GreenOps. This is the Google Cloud approach to drive transformation towards a carbon energy engineering and operation cultures. It has a goal to educate and enable IT people or IT experts to run software in a cloud for a more sustainable future. This is achieved by providing understanding, measurability, and optimization strategies that are needed to impact for the carbon footprint on a tech organization. So try to ask yourself in your cloud provider or IT partner to provide yourself such a workshop or approach. It will really help. One example of that is here the company Aeon. I think maybe you know the company. Here the company is using cloud data analytics to offer real-time energy consumption to energy managers, to helping them to make the decisions to reduce costs and CO2 footprint. Well, we are at the end of this presentation. So what we have learned so far. First, sustainability is it should be part of the business strategy, since it's not only helping the environment, but is also helping the business to differentiate from others and gain a competitive advantage. Technology, as you can see, could really help to achieve our sustainability goals, but it's really a journey. So it's not that you talk once and you forget. We could see that being in the cloud already is a great way to be sustainable, but it's up to us, architects, engineers, to ensure that we are building and thinking in a sustainable way. And lastly, please start a conversation. If you don't have already in your team, in your family, in your organizations, they all should be aware of what we can do something, and to please be informed and educate yourselves and others to be part of this greener IT revolution. Thank you.
Cool, thanks, Francisco. I love the talk. I love that we're talking more about sustainability. We had a fair few other talks about sustainability, and I think we should talk about it a lot more.
Yeah.
We haven't got any questions on Slido, but if you do, scan the QR code and ask the questions. I do have one myself, though.
Yeah.
So you talked about the cloud carbon emission tools there, where they tell you how much the CO2 is being produced from there. These are internal tools provided by the cloud themselves. Have there been any third-party checks on these tools, or can we trust them?
Yeah, I mean, there are some approaches that they are, or other third parties that try to get more data or insights to get more details of your carbon emissions. So there are other third-party companies that, besides what they say on AWS, what they say on Google Cloud, what they say on Azure, there's other type of methodologies that you can use to try to to capture, to measure what's you really are doing. Is what I show you, like there is a methodology which is called from the company from Etsy. It's called Etsy Jewels. That they find this methodology to measure this kind of how or what your workload is really impacting in the environment for certain patterns or certain factors. So there are already some others.
Okay, cool. So we are making sure and checking.
I mean, yeah, we should.
Cool. We do have some questions coming up. So is the size... Is the sustainability just measured by CO2 emission? The top sustainability companies use nuclear energy, which might not be sustainable from other perspectives.
Try to. Is nuclear? Well, I mean, I don't know what you're trying to say, but.
So I think the question here is: so nuclear energy obviously will give you no CO2. But obviously, there are aspects of nuclear energy which are not as sustainable.
Yeah, exactly.
So, the sustainable currently, are we only focusing on CO2 emissions, or do we look at other stuff?
Yeah, I mean, CO2 emissions is what is to measure. I mean, it's a unit that they all agree to kind of measure what we are doing, because it's the most. I mean, it's a unit, let's say, that they are having, because we need to have a common unit to understand. And CO2 is, I mean, there are some kind of scopes that are scope 1, scope 2, and scope 3. I mean, and we need to be aware or in consensus what's really this unit of measure, what we try to do. And they said CO2. But obviously, if we take nuclear energy, we have other type of contaminations that are not really sustainable for the future.
So do cloud companies tell you where the energy, the clean energy is coming? Is it just, for example, wind? Do they specify if they're using nuclear or not?
I mean, they said that you have that percentage of green energy. Some of them, they say that, some part of come from the grids and other part comes from free energy sources. But I mean, we should enable more transparency in these topics, because it's needed, and I think is what we are coming in the next futures.
Yeah, well, thanks. And another question: aren't cloud providers constrained by the energy sources available in most of the region? Should they be producing carbon-free energy for their data centers?
Yeah, I mean, it's a good question, because themselves, sustainability, as you have seen, drives really the innovation. Google Cloud, Azure, and AWS, and all the other cloud providers, they have been in research and investing a lot of efforts and money to create new type of energies. For example, Google Cloud, they start to research about a new type of battery, which was like a liquid battery to store green energy while we are, for example, in the night, or while we are having an excess of green energy. Or and Azure, that they are doing something inside of the ocean to cool down the systems. So there is a lot of research and things that they are doing for trying to get to this goal.
Yeah, I did see. I think you said Azure, where you place the container down in the middle of the ocean to cool down resources,
I think it's
so therefore not use as much
Scotland
energy.
or something like that. Yeah,
which was interesting.
Yeah, absolutely.
A few questions coming in now. Are there research in resource efficiency depending on programming languages runtimes, or is that considered unneeded optimization?
Well, I have seen, to be honest, I have seen this research about what language, I mean, how languages are being impacting the energy and so on. But I mean, it's really I mean, let's say that, for example, in the list I have seen like Python was the main one, and the greener ones were like the compiled ones because you have less usage of resources, you have less, I mean, just compile code, C, C++, and so on. And but it's not really how, I mean, about language. It's about how do you code that, because, for example, it's a common research that if you have a software problem, you will end to have or to use more hardware resources to came up or to solve the software problem that you have, a bug or something. But if you optimize your software, you could have better solutions, better resource utilization, and with that, sustainability, less emissions, and less resources.
Yeah, I think this is a programming language discussion which will never be
I mean,
finalized.
Exactly.
The next one is Rust. Everything's is going to be Rust. The last one, apparently, TypeScript. We don't like it nowadays. This was the latest one.
Rust was one of the greeners. Yeah.
Cool. Why are cloud providers not focusing on using less non-air conditioning to reduce energy consumption? Can't servers operate at higher temperatures?
Not focusing on use less air conditioner. Well, I cannot really answer that. I need to say it, or I need to ask to Google Cloud or other providers. But
I think if you're running, it's like when you're running your Mac and you start Docker engine on your Mac, things will start to heat up because you're using more energy, and you need to cool it down because otherwise the chip will probably
go
up
melt
in
down.
Flames.
Exactly.
And finally, did you experience any red flags to look out for that cloud providers use to make them look greener than they really are?
To look for the cloud.
So I think this is can we trust them, basically?
Well, yeah, there is so what they call, or what is called a greenwashing. That there are some companies, or there are some things that you said, we are all green, we are all sustainable, but we need to, but under the hood, there is nothing. It's just words. It's just paper. But I think this is going to be more regulated, and there's going to be more pushed, because, as you see, I mean, all they have signed the climate pledge for 2040, and some of the cloud providers, they have cloud-free emission by 2030. So there is only 7 years, and in 7 years they should do, and they should do what they said. And because we are in hurry, and they are in hurry. So we need to do something, and I think more regulated, more governments will push on that as well.
Cool. Thanks a lot. Keep on the discussion going. I think we definitely need to talk about it.
Yes.
We're running out of time. I fully agree with Francisco, but please join me in thanking Francisco.
Thank you very much.